Let's see. Day 6, wait for it. The ferry quickly brings you across island. After asking around, you discover that there is indeed normally a large pile of sand somewhere near here, but you don't see anything besides lots of water and the small island where the ferry has docked. As you try to figure out what to do next, you notice a poster on a wall near the ferry dock. Boat races open to the public. Grand prize is an all expenses paid trip to the desert island. That must be where the sand comes from. Best of all, the boat races are starting in just a few minutes. You manage to sign up as a competitor in the boat races just in time. The organizer explains that it is not really a traditional race. Instead, you will get a fixed amount of time during which your boat has to travel as far as it can. And if you win if your boat goes the furthest. As part of signing up, you get a sheet of paper, your puzzle input, that lists the time allowed for each race, and also the best distance ever recorded in that race. To guarantee you win the grand prize, you need to make sure you go further in each race than the current record holder. The organizer brings you over to the area where the boat races are held. The boats are much smaller than you expected. They are actually toy boats, each with a big button on top. Holding down the button charges the boat, and then releasing the button allows the boat to move. More boats move faster if their button was held longer, but time spent holding the button counts against the total race time. You can only hold the button at the start of the race, and the boats don't move until the button is released. Okay, I see it. For example, time 7, 15, 30. So these are the three races that we need to win. For the first race, the time is 7. For the and the distance is 9 that we need to beat, right? So we need to beat 9 in 7 seconds, which means that the solution to this problem basically is holding down as long as you can so that you are still making it in time, and that's how the furthest you can go. The first race lasts 7 milliseconds. The record distance in this race is 9 millimeters. Your toy boat has a starting speed of 0 per second. For each whole millisecond you spend at the beginning of the race holding down the button, the boat speed increases by 1 millimeter per millisecond. So because the first race lasts 7 milliseconds, you only have a few options. Don't hold the button at all, and then you have 0, alright. Hold 1, hold 2, hold 3, hold 5, 7, yeah, sure. Since the current record for this race is 9 millimeters, there are actually 4 different ways you could win. I think we are just going to calculate the furthest distance that you possibly can travel here. Determine the number of... Oh, wait. No. We need to determine the number of ways you could beat the record in each race. The number of ways, not the furthest that we can go. And then we multiply these numbers together. All right, understood. Yeah. Let's get the input. This is the example input. Let's open the project here, right? We're going to have day 6 example. And this is that. And we are also going to get our actual puzzle input, which is not that big either. Day 6. So we need to read the input. What do we have here? We have time, and then we have distance. Okay, so we just have 2 lines here. So input is we read to string the input slash day 6 example first. Then we're going to have the lines, and then on the first line we're going to have the yeah, let's do this. So we have times. It's going to be lines next. So the first line, right? We are going to strip the prefix from it, which is time colon, and then we're going to split the remaining using white space. Then we're going to parse every single thing, right? And this is our times. We're going to unwrap the parsing. And then similarly, we are going to figure out the distance. So distance on the second line is going to be stripped, and then the other things are going to be parsed. This is distances. So we have the times, we have the distances, and then the actual puzzle input. Actual puzzle input is we're going to zip izip, I guess. Specifically, we're going to zip the times with distances, and then we're going to map those into time and distance. We are going to construct the race with this time, and this is the distance. All right, and then we're going to collect that. So this is going to be the puzzle input is the list of races, right? Where the race has time and has the distance, right? So now that we have the actual input, what we are going to do is we are going to solve the thing for every race and then do the multiplication, right? So the answer is input. We're going to like calculate for every race something, and then we're going to get the product of those things, right? And then we're going to print out the answer. Okay, now what exactly do we need to calculate for every race? The number of ways to win this race, right? So let's see, what should it be? So the amount of time that we need that we're going to hold the button, let's say that the amount of time is going to be t, right? So the time that we're going to use to beat the distance, well, let's see how far are we going to go, right? So how far are we going to go? We are going to go for time minus t, because that's the remaining time that we are doing the race, right? And for that time, we are going to move at a speed of t, exactly, right? Because that's how long we have pressed the button. And in order to win the race, we want this to be strictly more than the distance, right? That's one of the things. And the other thing is that t should be less than time, or equal, I guess. It looks like over here we have the quadratic equation, right? So negative t squared plus time times t minus distance should be more than 0, right? Which means that t is actually inside the range. And the other range that we need to intersect it with is that t is from 0 to time, right? So those are the two ranges. We need to figure out this range over here. We can, by solving this quadratic equation, we can see what t should be in order for it to be 0, right? And then in between the two solutions is where the actual things are, right? So how do you solve the quadratic equation? We have a is -1, right? And then b is time. And then c is negative distance. And then the actual thing is negative b plus minus square root of the d divided by 2a, right? If I remember correctly. And where d is equal to what? b plus 4ac? Is that correct? Do I remember the math properly? I think you can solve this one though. Let's take a look at the input. J6. You can actually solve it by like iterating over all the different like variants. So I'm trying to solve this in like super fast time using math, but you can actually iterate over all the different variants. It's b minus 4ac. Okay, thanks. Oh, it's b squared. True. B squared minus 4ac. All right. So let's calculate this. This is negative race dot distance. We're going to calculate everything in floating point numbers, because the solution to the actual quadratic is going to be in floating points, right? Okay, let's calculate. D is equal b squared minus 4ac, right? If d is more than or equal, so if d is negative, this means that we don't have any solution to this, right? Which means that we can just return 0 immediately. This is the number of ways we can do it. It's just going to be 0. Otherwise, we are going to find both roots, right? So, like the left is going to be negative b minus square root of d divided by 2a, and the right is negative b plus square root of d divided by 2a. All right, so now we have these things. And what we are going to do is, since we should be strictly more than distance, we need to be strictly more than left and strictly less than right. Hold on, is our a negative? I guess we need to do the min-max. Is that there no function in std that, like, okay, sure, we do left, right, and then we do the maximum of left, right. And this is the actual left and right. So we find the minimum and the maximum solution to this quadratic equation. And then we do left is left dot floor plus 1. So in order to calculate the minimum integer that is more than left, where left is potentially a floating point number, we need to floor it and then add 1. Is that right? I'm pretty sure that this is right. And since we can have a little bit of like computation error, before flooring, I think we want to add some epsilon here. Let's say that epsilon is like 10 to the negative 9, for example. Okay, and then the right is going to be similar. We want to find the number that is less than right, which is integer, which means that we're going to calculate the ceiling of this and then subtract 1, right? Which in order to reduce the errors, we're going to subtract the epsilon here. Then we can also convert those into integers. Let's do into i64s. This is our range, and we need to intersect this range with this range, right? So left is left maximum of left and 0, and right is right minimum of this and the race time, because t is in this bounds, right? And now we have found, so left and right is basically the minimum t and the maximum t, right? Minimum t, and this is the maximum t, right? So now we just do max t minus minimum t. This cannot be less than 0, and then we convert that into a u64. So I have calculated the product to be 168. Is that the correct answer for the no, it's not. So let's inspect the things that we actually have. So we have found 3, 7, and 8. Oh, wait, hold on. The number of ways, if we know the minimum and if we know the maximum, is not maximum minus minimum, right? It's maximum plus 1 minus minimum, because we want both maximum and minimum to be included, right? And that's the problem that I had. So there you go. We have calculated for the first race. We have 4 ways of winning. For the second race, we have 8 ways of winning. For the third race, we have 9 ways of winning. Then we multiply those together, and we have a 288. Just like here. So now we have the solution, and we can run this instead of on the example on the actual input, and then we just submit our answer, and this is the right answer. Like I said, the way I did it is using math and solving quadratic equations, right? But you don't need to do that. You could instead just iterate. Let's write a simpler solution for this, right? Let's do here calculate using math. Solve using math is pretty long, right? Because we needed to solve some math here. But let's do solving using brute force, which is going to be much easier. Solve brute for the race. So all we need to do is calculate the number of ways we can win. So we are going to iterate for t, and we are going to So we're just going to iterate over all the different times that we can that we are going to hold the button, which means that our actual speed is going to be equal to t, and the time left is going to be equal to raise time minus t, right? So the distance that we are going to cover, right, our distance is going to be equal to time left multiplied by speed, right? And if our distance is more than the distance that was like the record before, then we actually win. So wins plus equal 1, right? And that's the entire solution here, I think. So that is much easier, right? But this requires us iterating over here. Let's try, and instead of solving using math, solving using brute force, right? So we should get the same answer here. And we did get the same answer, right? So this is so this solution is much simpler. We have not seen the second part of the problem yet, and maybe we will have to use the math. But I don't think it's hard. It requires more time. If they have given the input that requires us to iterate, like if these numbers were much bigger, then we would have to use the math, basically. Let's take a look at the part 2. So in the part 2, as the race is about to start, you realize that the pieces of paper with race times and record distances you got earlier actually just has very bad kerning. What is a kerning? Adjusting space between characters. There's actually only one race. Ignore the spaces between the numbers on each line. Oh, there you go. Now we are actually going to have big numbers, right? Now we're actually going to have big numbers. And if you take a look at the actual thing here, so our actual number is going to be 45, 97, 72, and 95, which means, I mean, we can still iterate over that stuff, to be honest. It's not that big of a deal. I think that number is not that big. So yeah, we just calculate this differently, and now you have to figure out how many ways there are to win this single race. So we literally just changed the way we are doing the input. So instead of doing that, can I just join those together? Combine all iterator elements into one string separated by the separator. There you go. We are just going to join all the little parts into one string. So we are going to only have one race. We only have one race, which has the time and the distance that we have solved before. And here's our solving, right? And all we're going to do, our answer is literally just solving for the inputs, right? Part 2. Let's see. For the example, 71 503 ways, 71 find the 503 ways, right? And then we can run this for the actual input. And as you can see, I'm not even running in release mode, and it still was computed really fast. And we can also try doing this using math. Solve using math. And let's see if the answer is still going to be the same. And the answer is still the same. So yeah. Yeah, this day task is pretty simple, it seems. This is the right answer.